Good afternoon, everybody, and welcome to another of Spark's webinars today. Thank you very much for joining us. We're delighted to showcase another of our excellent companies that we've got on the platform, which is currently live, as you probably know. It's already received significant levels of funding from both the Spark investors and also from other private investors, and of course, Enterprise Ireland as well. And that, of course, is Embryomics. We're delighted to kind of welcome them today. As you may or may not know, Embryonic is an Irish medtech company which is pioneering a non-invasive metabolomic-based embryo selection called PMTBC that has been developed, been in development for over 12 years and using data of mass spectrometry to improve IVF success rates. The technology is supported by granted patents that are an ongoing clinical validation, both here in Ireland and in Germany, and is positioning Embryomic at the forefront of fertility diagnostics. We have joining us today, leading the company, Robert Brennan, who is the CEO of the business. Robert is an experienced entrepreneur with a bachelor's in business studies and an executive education from Columbia Business School. Robert successfully built and scaled RDT Care, which was a COVID testing firm with over 1 million in revenue, and now applies his extensive commercial and strategic expertise to accelerate Embryomics growth and adoption into the fertility markets. We've also got joining us the Chief Scientific Officer, Professor Ray Isles, who brings world-class scientific leadership along with academic and biotech track record. This is including roles as a research professor, university dean, and a founder of technology platforms and diagnostics. He has extensive IP and mass spectrometry experience and co-founded Embryomic to translate cutting-edge scientific science into clinical tools that make IVF more effective. So that's Embryomic. And please, Ray and Robert, if you could open up your cameras and join us, that would be brilliant. Thank you very much. So the guys are going to give us an 8-minute, 10-minute presentation, and I'm going to ask them a few strategic questions. Hopefully, they'll give some good quality responses too that will help frame for your own decision making. The reasons why Embryomic should be a good investment for your hard-earned buck. But also we will have the Q&A open as well. So please, if you've got questions of your own, please put them into that rather than the chat. So the Q&A specifically, and both Fergal and I will pose those questions to the boys at the end of the session. So Robert, Ray, if you'd like to open up your presentation, please, which is there, and I'll leave it to you. I'll go dark, and I'll see you in about 10 minutes' time.
Thanks, Chris. And thanks for all the attendees today joining the call, and we're really excited to showcase what Embryomic is about. So I'm Robert Brennan, I'm the CEO of Embryomic, and today I'm just going to quickly run through our pitch deck, and then Professor Ray Isles will just talk briefly over the science and how it's been created. So I'll just move my sheet across. So in terms of Embryomic, Embryomic is basically transforming IVF outcomes within the using the PMTBC test, which is patented based on AI/ML driven and has a non-invasive embryo viability test built on over 12,000 patient samples. Our technology at the minute delivers over 42% increase in pregnancy success rates, reduces treatment overhead costs and risk, which is essentially solving a major pinch point in IVF treatment. It's backed by strong clinical validation, so it's built on over 12,000 samples with a 1,828 validated data set, and the IP. Embryomic is uniquely positioned to lead a multi-billion opportunity. In terms of the journey, it all started back in 2004 when Professor Ray Isles started looking at biomarkers affecting IVF outcomes. And our test was patent approved in 2020, which is owned by the Metaprom. So we've licensed the patent down to Embryomic. So we've set up our lab in DCU, and now we are starting to do our commercialization, pre-commercialization. In terms of IVF, that's the problem itself. So as you know, 1 in 6 couples are struggling to conceive. the average success rate or the average rate of a patient getting a successful outcome is 30%, which is across all four brackets, which is pretty low. And over the last 20 years, any new technologies that have been used, so be it PGTA, AI imagery, still have an increase in success rates. In terms of the market size and why we're targeting the IVF market at this minute is the global market is 32 billion and it's grown with a compounded annual growth rate of over 8%, which is then forecasted to give us 68 billion forecast revenues by 2034. In terms of the global volume, there's over 3 million cycles, but our focus is initially going to be on Europe, which is about 1 million cycles. But then we drill down into regions within the Europe, which is Germany and Ireland initially. So there's going to be high demand and then there's low success rates. In terms of the PMTBC test, what is it? So it's essentially we take an embryo at day 5, day 6. We take the media that's been grown in and put it in a dish for 2 extra hours. We take the liquid that is in that dish for 2 extra hours and then we analyze it through an AI scoring, which will then give a viable implementation prediction rate. So the key benefits, as I explained, 42% increase over in pregnancy success rates. So if you can take that 30%, we have been able to show that it goes to over 72% at the minute. And we're CE-IVD, SIMD pending. So SIMD is so far as a medical device, so it's not IVDR. In terms of the mass spec, so we collect the sample, analyze it through the MALDI-TOF, which is a mass spectrometry ionization machine, and then we run the scoring through our model. As you can see, there's 4 different brackets. So age profiles, less than 35, 35, 37, 38, 40, and 40. So the increase in success rates are all different. So as a patient's at 35, less than 35, poor success rates is usually around 40%. We can increase it over 63. But when you go to the age of 40, so typically a 40-year-old patient would have a success rate of about 7 to 8%. We can increase that by up to over 20%. So that's nearly a 3-fold increase. In terms of the competitive landscape, what other technologies are out there, i.e. complementing the embryologists within the lab? So you have typically what they use is morphology, which is grading the embryo using subjective. It's using looking how it looks. Is it looking good, looking bad? And that's the Gardner score. Everyone has been using that for the last number of decades. In terms of then other competing technologies that add to the morphology would be PGTA, which is essentially analyzing whether there's abnormality within the chromosome levels. And that has also shown to not improve success rates. And America has come out in terms of the American Society of Reproductive Embryology, come out and basically stated that there's no increase whatsoever. Then you have AI imagery, which is looking at day-to-day growth of the embryo. And that also, the Lancet has wrote about AI imagery only increasing it by a small number of variables. But when you compare ourselves, we're both non-invasive, the turnaround is quick, we're quantitative. Our success rate at the minute is shown to be over 72%, which is impact. Scalability, it's highly scalable, and our workflow is very, very little impact to the embryologies whatsoever. So we've been designing the test to make sure that it can go into the lab without any excess. In terms of the MDR, so we're looking at software as a medical device. Now we stated Q1 2026, but given that the little bit of delay in funding, a little bit of delay in science, that's going to go into Q2 this year, but it shouldn't really impact it because it's class 1A. In terms of the business model, as I mentioned, there's 1 million cycles globally within Europe. Within Ireland, there's about 11,000 cycles, and within Germany, the first market that we'll be focusing on within Ireland, there's 150,000 cycles. So our market that we're looking for is to identify those markets, i.e. Ireland and Germany, get access to that and utilization even if you're looking at utilization of 50% of those markets. Every 1,000 cycles within a clinic will generate over €1 million revenue based on 875 per test kit of 5 or per 3. So it's very scalable, very, very cash rich, very quickly. So here's an overview of what we're looking to do. 30,000 cycles is our target, 150,000 embryos, which will then generate up to over 26 million in revenue very quickly. Assuming we do really well within Germany and it rolls out quickly, we'll be looking at then focusing on Japan. And the reason why we're looking to go across straight away to Japan is that 11,000 cycles in Ireland, 150,000 cycles in Germany, but in Japan there's 500,000 cycles. One clinic alone in Japan does 25,000 cycles. So we're looking at high volume clinics. In terms of the leadership of the team, I'm Robert Brennan, CEO. We Professor Ray Oils, our clinical lead for Germany and global is Dr. Sarah Nasser. She's a clinical consultant, obstetrician and gynecology, and we have an interim CEO. In terms of our advisors, then Tony Walsh is the ex-founder of Sims Fertility, which is exit. David Hansen's the ex-CEO of Cooper's Global Fertility Solutions, and then Green Cool and Sims, which is owned by Virtus, is helping us as well. As I say, the market, testing as a service, healthcare partnerships, licensed into technology, but year 1, year 2, Ireland and Germany, with year 3 then going into Japan. As I say, the rollout, Germany, Ireland, Japan, UAE, and then licensing into America in year 4. This goes through and just in detail, just the overall go-to-market strategy. 1,488 clinics in Europe with over 5 million blast assists, and our addressable market then is obviously 5 million blast assists per year. Our targets will be Germany, Japan, and thereafter. In terms of the CE, IVD, SAMD, it's more or less ready to be submitted. We are doing usability validation studies within Ireland and Germany, which are going extremely well, just to add further clout to the application, but it's actually not needed at this minute. The core tech is mildly tough, and then our pricing strategy and market entry strategy is using the pilots, the SIMs, the clinics in Germany to turn them into full commercialization clinics, and then using key opinion leaders within the region, and then looking and leveraging off the scientific publications and conferences like ESRA and ASRM for further credibility. I won't go into detail in the marketing strategy, the rollout, but as you can see, it's pretty identified where we're doing and what we're looking to do. But the pricing model is business to business pricing model. Clinics will pay for 5 blast test kits and the opportunity will be for volume discounts. Revenue 1, 4, and 8. We believe we're lowballing the numbers. We believe we'll get 15, 16, 17 million within year 3. And the reason why we believe that is that every clinic that does 2,000 cycles and is a utilization of 50%, i.e. conversion of each 50% of the patients who use our test, will generate revenue, which equates them back to generating and signing up minimum of 8 to 15 clinics by year 3, which we feel is very reasonable. Financial projections there, we go into that in detail, but most of the cash that we're raising here for today is essentially to ramp up and use for working capitalization, team expansion, and then laboratory scaling within Germany. Cash flow break even, we expect to be within 12 to 18 months post commercialization launch, and the business model based on full end-to-end solution to fertility clinics. I just want to push on to the science because I'm just conscious of the time, and Ray will just go through briefly about the science because we haven't really given much detail on the pitch deck. So Ray, I'm just going to hand it over to you, and I'll manage the slides page for you.
Yeah. Okay, thank you. I am going to rush. I'm going to give you some insight into how this technology works. Now, there are some very important features. Is that we're a non-invasive test. We don't touch the embryo at all. We're just looking at the culture medium which the embryo is growing in. And we only need very little amount of that culture media. We only need 1 microliter. And that 1 microliter of culture media is put into the latest advances, a benchtop multi-top mass spectrometer. And what that does is resolve all the molecules that are present in that culture media. And we're talking thousands. And we've used AI machine learning to help identify the ones that are associated with good outcomes. And from that, we then did a Bayesian analysis to produce a predicted scoring. So we've used AI machine learning, but very selectively. We're not blind to this. We have to know what's going on. So that was part of our development. Next slide, please. So let's just get you some of the background and what the problem is. So IVF is great. It's fantastic for people who can't have a child. But as you get older, the probability of you having a successful IVF treatment and a blastocyst that implants and leads to a birth decreases with maternal age. Now, what is the problem here? Is it the mother and in terms of her own physiology able to take a child to term? No, it's not. Because if you were to take a donor egg from a woman, say in her 20s, and use that donor egg and fertilize it with the male partner's sperm, let it grow and then transfer it to the same mother, the success rate is restored. So it's all down to the egg. Next slide, please. So what is going on with the oocytes, these human eggs? How are they aging? Well, people jumped onto the genetic bandwagon, and I've got nothing against genetics. It's just it can be over extrapolated in terms of what's going on, and people thought, oh, it must be genetic abnormalities that are occurring. And then PGTA was born. And this is a technique where you have to rip off a couple of cells, extract the DNA, and they said there must be chromosomal abnormalities. Well, this has been going for nigh on 20 years, but there are lots of problems with this. And as Robert has already said, it actually has not increased success rate. Yes, it is associated with increased miscarriage, but not with the success rate of IVF. So we had to go back to fundamentals. Next slide, please. I'm going to go very quickly through this because of time. But basically, what we have with the oocyte or the egg that is produced, we have the biggest cell ever produced in the human body. You can see it with your visual eye. It's as big as a pinprick. It's the only cell you can actually visibly see. Now, when it's produced, this large, massive cell, and it really is huge, has lots of mitochondria. Now, not just lots, it has more mitochondria than you would find in a highly energetic heart muscle cell. Any other cell has about 5,000. We have 500,000, approaching 1,000,000 of these mitochondria. So something is going on with there, and it's something that was missed in people's enthusiasm for everything genetic. Next slide, please. And these mitochondria were very different in their structure. The typical mitochondria you might see in a muscle cell, and here they are packed into a muscle cell, giving all the ATP energy, which you might have heard of, so that you could do muscle contractions and fibers. You'll see it's this big elongated mitochondria and all these enfolded membrane cristae, because on the surface of these cristae is where you produce ATP, which is the energy consumed to cause the muscles to contract. Now, that isn't actually the typical mitochondria you see in every cell. If you look in a liver cell, for example, you see there's very few mitochondria. They're round, and they've got this matrix here. And that's because a lot more biochemistry is going on in mitochondria than actually seen anywhere else. Chris, I'll be very quickly. I can see you're appearing. But if you look at the oocyte and the early blastocysts, you can see that they are very, very funny mitochondria at all. They've got these lipid granules associated with them, little lipid food storage, and are very dense with very, very few mitochondria. Next slide, please. And what has been discovered that these mitochondria are very, very interesting. There are up to 1,000,000 of them. They're associated with a structure called the endoplasmic reticulum, and they're often sounded by these storage lipid granules. So they are very different from what people think about. Now, why is this so? Next slide, please. This is because mitochondria do a lot more than just produce ATP, which occurs with this enzyme sequence here stuck on that membrane of the cristae, the enfolded little fingers that you see on the mitochondria. You don't have that because you're not producing lots of ATP, which one might think was what was going on. But in fact, in that matrix is the TCA cycle, and it's producing all of the material that you would need to build new cells, nucleotides to make new DNA, fatty acids, cholesterols, amino acids, porphyrins. All of these are from that mitochondria. So that's why it's packed with them, because they're going to be used. And there's a storage issue here. Next slide, please. And this is where the concept that we've got with our PMT test. What we were saying is, biologically, you are born with a set number of oocytes. You don't produce any more after you're born as a female. They're sitting there waiting to be activated, and the number drops dramatically, but they're just sitting there. You've got not any brand new ones whatsoever. So they are aging. We've got an aging oocytes. So what happens is that they are kept alive and fully charged, and I'm going to use that word immediately, because in the ovary, they're being fed by these nurse cells called granulosa cells. But once ovulation has occurred and they're released, they're on their own. They are not relying on any metabolic signals, resources coming from the maternal blood. They're on their own in this relative anoxic environment. So there's very little air for them to metabolize. So they're running on this internal battery. Now, once they're fertilized, they start to use up that internal metabolic battery of resources. So, of course, if you're aged and your battery supply is low, the probability of getting to here is low, and you've still got to have sufficient battery energy for this blastocyst, which is day 5-7 in the laboratory, well, yeah, 5 to 7, has to actively implant into the maternal circulation, and that is like implanting back into the mains, so it can draw all of the necessary resources, raw materials to start developing into an embryo. So, next slide, please. What we have is a thing when you're aging is that you might have started off with lots of oocytes, which are fully charged, but as you get older, some of these are going to age. And like rechargeable batteries, the actual capacity to hold resources, which is going to be consumed very rapidly, is decreasing with age. So what you need to do, next slide, please, is actually test that metabolic battery. And this is what this PMTB test is doing. I will stop at this one. I could talk for hours on this technology, but I won't. So basically, what we're looking at is signature molecules that are released into the culture media from that mature blastocyst at the stage at which you're going to transfer it to the mother. We can look using high throughput mass spectrometry to thousands of peaks. There are actually 35 that we have picked out that are key. And there's particular mathematics involved in scoring them. And what we can do is say, well, that profile looks like a very highly charged blastocyst, which is very likely to succeed. This other blastocyst, it may look good, but the metabolic profile we've got on it is very poor, and its probability of implanting and giving a live birth charge is very low. And that's how we can score the blastocyst. I will stop there. I've got more slides for questions. If anyone wants to go into a little bit more detail.
That's very good, Ray, and thank you very much indeed. So, Robert, perhaps you can just unshare your screen now. I mean, just for everybody's use and in a layperson's and I've looked into this as well. What Ray and Robert have told me in the past is that they're analysing the secretions from this embryo, from this blastocyst, and determining from the secretions of it, i.e. in the fluid outside the egg, not touching the egg at all, so it's not invasive, analyzing that secretion and determining whether that's a good egg or a bad egg. If it's a good egg, it'll go on to implantation. If it's a bad egg, it'll be put to one side and not used. So they're increasing the success rate by choosing those blastocysts, by choosing those embryos in a more scientific manner than has previously been done before. So that's my layperson's interpretation. Hopefully that kind of gets it across as well. But thank you very much, guys. That's very, very useful. So I'm going to ask you just 2 or 3 questions first of all, and then we'll go on to the questions that have come in from the audience. But guys, you recently announced that Conor Moran was going to be joining you as an independent non-executive chairman. How does his experience in the venture scaling and board governance enhance your ability to execute your fundraising and the governance around that? And what signal do you think that this is going to give to prospective investors?
Yeah, I'll take that, Chris. Thanks a million. In terms of Conor Moran joining, I think we're pretty lucky to have Conor willing to join the board. Conor's background, he's a qualified accountant, KPMG, ex-AIB Corporate Finance, ex-managing director of a large asset management business in Dublin, has experience of going in, cleaning up businesses, fixing businesses across a number of generic industries, including medical, including pharmaceutical. So he has a broad scheme of knowledge. And then on the side of the independence, he'd be able to bring to the board a total independence, credibility to the side. But the reason why Conor was approached is ideally, whilst we're raising money today, we're also looking at the exit. So with Conor's ability and his contact base around the world, and able to structure deals, I think Conor's ability is second to none. So that's the reason why we also brought Conor on board. So it's not just being independent, it's also how can we use his skill set, his network to allow us to look at potential exit within the 4-year period after EWS.
Very good. Let's move on to the validation that you're doing both here in Ireland and in Germany as well. You're executing your CE focused clinical validation across the two countries at the moment. Can you elaborate on how the milestones will materially de-risk that submission to the CE and accelerate the pathway to commercial readiness?
Yeah, so the validation in Ireland and Germany has gone pretty well. I could be overconfident, but it's gone very, very well. In terms of the CE approval, it's CIVD SMD Class 1. We've been given recognition by our regulatory guide, which essentially is a self-certification. So at this minute, we could go and lodge our application for CE approval, given that we have a data set of 1,828 that is fully validated. So we don't really need the clinics in Ireland and Germany, but the process of Ireland and Germany is to help us open doors for commercialization. So that is the key focus. So it will help us on two strands. One, in terms of getting CE approval, having a German clinic, having ethics approved within Germany, which we already have, lodging that within our application adds strength. But two, given that we will do validation within a large German clinic, that will help us then turn that clinic into a commercialization clinic, i.e. to start being a customer and then adding other customers within Germany. So it gets our foothold in Germany, gets our foothold in Ireland. So there's two strands of why we're doing that at the minute.
Very good. Excellent. Okay, and final one from me before we go on to the questions that have come in. So the sample collection that's underway with your German partner and the validation progressing strongly. How do you see the developments in strengthening Embryonic's position with the strategic partner and early commercial adopters?
Yeah, so in terms of the validation and what they're seeing, coming out in terms of what we're promoting in terms of what they're seeing on our results. They're still not using it for their own end to end, but what they are seeing is that the recommendations of the high probabilities of embryos that we're recommending within our scoring scheme versus what they're getting, and we are close to over 80% accuracy at this minute within the clinics, which is really, really strong. So in terms of strengthening within the clinics, assuming that continues, which we don't see why it shouldn't, they will get big opportunity to use our tests quicker than any other clinic on site, which will then add value to their own clinic base. So yeah, that's the reason. Ray, do you want to add anything to that?
No, not at the moment. I think there are some questions where we can actually go on a little bit more and go into this, and we can address it more there.
Talking of which, Fergal, perhaps you were like to pose the first one.
Loads of really good questions here, and so thanks everyone for sending them in. I'm just going to roll in a few questions together. One just on the IP side. So when did the current patents expire? What happens after that? And then probably the second part, which is a separate question, is seeing that Japan is your third country in your expansion plan, why would you not lodge a patent there?
If I can address that, the straight question is we've got another 10 years on the patents, but these patents were very early and talked about the general approach of using mass spec and spectral pattern recognition, which is very, very broad. What we have done subsequently is we've identified particular markers, and then we've developed an algorithm. Now, we don't disclose that. It's like Coca-Cola secret sauce. So that extends the IP lifetime much, much more. So it takes us much, much further. We've been very careful about the IP strategy because once you disclose, that's a lot of information. People will find other ways of going for those markers. So actually, we've been very careful with the IP strategy. So the broad pattern is the approach because they were before anyone else started doing this. And now it comes into the technical detail, which we do not disclose. We're keeping that as Coca-Cola secret sauce.
Perfect.
Good. Have you received regulatory approvals for Ireland and Germany? Well, perhaps you can just talk about the CE approval and what will happen with that. And you mentioned, Ray, you could apply tomorrow if you wanted to, but perhaps you can elaborate on that.
Yeah, I'll just take the first part, Ray, and then you can do the second. So in terms of regulatory approval in Ireland, at this minute, there is no requirement to have our test regulatory approved. Okay, PGTA is not regulatory approved, AI imagery is not regulatory approved. So the process currently within Ireland is that it has to be a change process with HPRA. So essentially, the lab has to showcase that it doesn't impact it. So we can go to clinics today and start using our test, but we don't want to do that. We want to be the first company to have a CE-approved embryo selection test, and that's why we're going down that route. So at the minute, we don't need to be regulatory approved, but in terms of Ireland and Germany, we have ethics approval in Germany for the validation. But having a product come into the market CE approved and rubber stamped that it's CE approved gives further credibility to the business. Secondly, PGTA is not CE approved or FDA approved yet. It's a $1 billion business, but they're coming under class action lawsuits because there was no validation, nothing done on them. So we want to have everything all ticked to allow us to go out and gather market share quicker than PGA. Ray, do you want to add on to that?
No, I was. You've just said what I wanted to say. Really, is that we want to be way above the current Wild West status that has been. There's been a lot of complaints, and there's a lot of end users who are very upset a way that a technique might be included which has not been validated. We are saying we are going through full validation with CE marking to show that we've done everything, and we've been very mindful of the information that comes out and the way, and that no couple is being misled or necessarily
it's essentially to ensure the robustness of our test and credibility. That's essentially what we're doing.
Yeah.
Sorry. Perfect. I have a question here, good question maybe for you, Robert. When can investors expect an exit, and what do you project will be the return on investment? So when, who, and how much?
Yeah. So when in exit is always on our horizon. As I mentioned, bringing Connor on board as an independent chairman, and plus his skill set in terms of what it's deal structure and under EWS, you have to hold the investment for 4 years. Okay, so ideally we'd be looking between 4 and 5 years of an exit. Who would do it? Who would acquire it? So the exit opportunity in terms of the vehicle, we would obviously look at being acquired by one of the larger diagnostics firms within the IVF industry or one of the larger providers. So I won't mention names because it's not ideal, but there is a number of companies. There's 3 particular, and we're already under NDA with one of them.
Very good.
And in terms of the exit, the valuation, sorry, in terms of valuation, we'd be looking at it excess 30 million.
Very good. Okay. Seeing as Japan is your 3rd country in your expansion plan, would you not lodge a patent there?
Well, as I've said about the our strategy is we've got a broad pattern on the approaches, and lots of people. Half of it is that people are adopting this technology because we've come in. I was, for over 30 years, I've been involved in mass spectrometry, clinical mass spectrometry, and this technology. We were ahead of that wave. That wave of everybody's coming up behind us. Now, the big thing we realise is that there are various nuances to techniques. You can change them. If we tell people in a patent submission that we are measuring these particular markers, we do give it away. So we've decided to do a little bit more of the secret sauce Coca-Cola approach from this point on, and that's where we can hold up anyone else. We just don't reveal it. We've got a lot of preprint publications come out, and if you do read them and think, God, they're giving it away. No, I've sort of not pinpointed actually the markers that we are using, but just indicated the class of biological markers that we're indicating. For the scientists out there or people who are really interesting, we've got a set of preprints which really explain how we've moved this technology in, and everyone's going, oh, of course. So what is that? And we just don't tell you what that is. We've had to be very careful about it because of the IP issues.
Sure. Virgil.
Yeah, so I have a question here just regarding a next round. Is there scope for another round of funding, Robert, and if so, when?
Yeah, so ideally we were looking to raise 2 million, but we're looking at doing that in 2 tranches. But if the 2 million was available, we, as I explained, EI is at the table. We are also in talks with 2 large medtech syndicates. We're also in going through due diligence with a venture fund out of Germany. So it all depends on whether the 2.2 million lands. If all that lands, we don't envisage any next round thereafter. But if we're happy to cut it at 1.2 million to execute our milestones that we've outlined, and then that will give a valuation uplift thereafter. So it all depends on the appetite. At the minute, there seems to be a large appetite both here in Ireland and within Europe and pan Europe. So we don't envisage. We believe we'll close out the round over the next 2 months.
Very good.
Fantastic.
Okay, final kind of technical question. Are you doing any computational modeling simulation in conjunction with the clinical trials?
That can be dangerous, but yes. My experience is that AI machine learning can overinterpret. So what we had to do is actually remodel based on Bayesian. So and say, well, what was how did this really fit? If I didn't use the model, can I say, well, with certain markers accumulating, were I getting greater probability? So we have been, and we've got to say, well, let's get down to actually making sure that everything works hard. So that's what we have done. We've made sure that this is a very robust model, and the algorithms are actually very, very solid, because we know exactly what the markers are and how they're interacting. It's not black box algorithms.
Very good. Very good. Okay, guys. Well, listen, I think we'll leave it there for the day. Thanks very much for answering those questions, and thank you very much for posing those questions to the audience. Hopefully that's kind of shown you a little bit more about what Embryomic is all about. And hopefully you're kind of can understand it a little bit better now. And as you can see on the site, it's doing very, very well. Good amount of funding in already. The valuation is 6 million pre-money valuation, and of course it is 50% EIS for those of you who are qualifying, which I guess most of you are for that. So please, it's going to be closing probably next week. So there is only a short window for you to do some more research into it and hopefully invest after that. So please don't dilly-dally and get those investments in. Guys, thank you very much for your time today, and thank you very much. We'll see you all again soon. Thank you.
Thanks for
Thank you for listening.